Okay, so welcome to the second day overview of spatial data. There's some general terms when it comes to spatial data that can be useful to know. There are several types of data. Broadly, it's broken down into raster and vector data. So raster data being where each pixel is encoded with the attribute and represents something on the ground, and vector being where you have points, lines, and polygons that define the edges and locations of the different features. So yesterday when we were looking at imagery, satellite imagery, drone imagery, that's all an example of raster imagery. When you then trace features like the outlines of buildings, the roads, lakes, and things like that, you're creating vector data, defining those corners and edges using points, the connections between them into lines, and then polygons where you close those lines and create a shape. And then attributes. So in a raster image, raster data, each pixel is encoded with a number. So in the case of a image, you would have the RGB values for the red, green, and the blue that result in the color you see. This also could be something like elevation or rainfall or something like that. When talking about sources of data, one that is worth mentioning is the Humanitarian Data Exchange, HDX. And this is a website that agencies like the Red Cross, OCHA, the UN, and other organizations use to upload and share data that generally has some sort of open license applied to it. Some of this data is non-spatial in nature. Some of it is very much spatial. So there might be things like administrative boundaries up on this website. And also some of it is data that can be tied to spatial boundaries. So something like census data or other assessment data that can be matched to something like provinces and municipalities or something of that nature. For data sets, OCHA and other organizations have defined CODS, C-O-D-S. You can see it might be kind of small on your screen, but you can, in the list of possible filters over here, it's CODS. These are common operational data sets. And so those include things like population data and administrative boundaries, some of the basic information that is key in humanitarian operations in countries. Also, you can see you can filter specifically by geodata and administrative boundaries to look for information that you could maybe use on a map. The one we're going to spend more time on as a source of spatial data is OpenStreetMap. You may have probably heard of this before or encountered it or maybe even mapped. An OpenStreetMap is a map of the world created by people like you and free to use under an open license. So what this is the map isn't owned by a company or government. Anybody can log on, create an account, and contribute what they know about the world to the map and improve it, make it more detailed, update it. It's free to use under an open license. So whereas Google has a pretty good map of the world, when you log on to maps.google.com, you can only use their website, their interface, to interact with it and to view the data. If you want to do an additional analysis or style the map in a way that's unique to you, Google doesn't let you do that. With OpenStreetMap, if you go to osm.org, it does have a styled map that you can look at and pan around and zoom in and view the world as the data in OpenStreetMap shows it. You can also download that data itself, so the points and lines and polygons, that vector data behind it, and style it or analyze it how you want. So in Google, you could maybe like log on and type in police stations or Starbucks and find all of those manually by counting the number of entries the search returns. With OSM, you could actually download the building data for a city and then look at all the attribute tags and analyze automatically, extract out the coffee shops or the schools or whatever else you were interested in looking in, making the whole process much easier and much more powerful. And this screenshot is showing humanitarian agencies have embraced OpenStreetMap. Kind of one of the first major times they did this was after an earthquake in Haiti in 2010, where volunteers came together and started to trace from satellite imagery all the buildings and roads and Port-au-Prince and the rest of Haiti, helping create a map, a detailed base map that the responding agencies and organizations could then use to better reach people in need, people affected by the earthquake. And then also those agencies on the ground were able to fill out some of the details and more easily share the information among them as they figured out the extent of the damages and the changes to the city based on the destruction from the earthquake. This is from a more recent humanitarian response, so the Ebola response in West Africa in 2014. And you can see that some 2,500 people made more than 12 million changes to the map, updating the buildings and roads in that area and other details to the map. With OpenStreetMap, one of the big strengths of it is that anybody can contribute, and so people can contribute local knowledge. There's only so much you can tell when looking at a satellite image or collecting data from somewhere you don't live. Local people, when adding details about their community, about their town, know the details. They know, which building's the school, which building is the health post, where all the shops are, and they know what's important to them. If they need a map, if someone really loves coffee, they're going to want to make sure all the coffee shops are traced in, and so that allows them to add what's important. If a community is having issues with garbage and trash, they can actually go out and add the informal dump sites and the pickup locations for the city and stuff like that to the map, and help share and understand the distribution of those things, where those things are. And they know it's appropriate too. They're not going to add any details that might be dangerous for residents or put someone at risk. Briefly, talking about the OSM governance. So overarching it all is the, sorry.
Hello, could you please mute your microphone because it's disturbing others?
Sorry, and I can also can mute people. I just was slow on that one. So the OpenStreetMap Foundation is a nonprofit that kind of oversees and guides the entire project, encourages the growth and development of the project. There's also OSM local chapters. So within different countries, There's organizations that can form and apply to be a formal part of the OpenStreetMap group. There's an OSM US chapter that I've been a member of. There's also an OpenStreetMap Philippines nonprofit organization that aims to promote the use of OpenStreetMap and the quality of the map within the Philippines. So the data in OpenStreetMap. It's very similar to the vector points, lines, and polygons we talked about earlier. The terminology is a little bit different. So in OpenStreetMap, there are nodes and ways, and then also relations for sometimes complex features like multi-polygons. So if a territory or administrative area consisted of two separate areas, or like maybe if 2 or 3 islands were part of a municipality, the municipality would be a multi-part feature. And so you need a relation is the term for when there's these things in OpenStreetMap that are across different areas. And the attributes for these features are stored as key value pairs. So the key being kind of the topic or category, and the value being the detail for that particular feature. There is a map features wiki that describes all of this in a lot more detail. The community of OpenStreetMap kind of comes together and agrees on some of the most common tags, and anyone can make a proposal or suggest changes to the system that would make it more appropriate, more flexible, more able to represent all the features you might encounter in the world. And it's a free tagging system, so even if something isn't defined on the wiki, there's nothing really stopping you from creating your own tag, although it's frowned upon to go in and kind of make new tags that aren't going to fill a purpose or a need. On the wiki, tags are grouped by that key. So building is one of the keys, and you can see here that it might be building equals school, or building equals university, or building equals college. And there's descriptions for each of these for when those should be applied. For a lot of the more common tags, there'll be a detailed page describing how that tag should be used. So here we can see the page for building equals school, and it goes into a little bit more detail about what this should be used to describe. And oftentimes there'll be helpful mapping guidance. So here, talking about mapping the school building versus the school grounds, that you probably want to add name equals and an address, and linking to the pages that describe how to add and use those tags. There's also sometimes country mapping conventions. So there's a page on the wiki put up by, I believe, the Philippines community that talks about the conventions for kind of Philippines-specific tags. So on this page, it will describe things like the proper tagging for barangays, something that isn't going to be outside the Philippines, but it's an important thing to have consistent, to have the same across all the Philippines, so that when you're making a map, when you're using that data, you know how to find the barangay name and identify those places. There's a lot of resources to learn more about OpenStreetMap. LearnOSM.org is a good one that kind of goes over a lot of the basics in detail, and gives you some details about how to create an account, how to edit, how to log on, and things like that. There's a variety of different ways to edit OpenStreetMap. If you go to osm.org, that's the main landing page for the map for the website. On there, you can see the OpenStreetMap tiles. So the map, as they have decided to style it, kind of a general purpose style, but nothing stops people from creating their own map styles. And the map is just a way to let people see and explore what's there. There's a lot more underneath that cannot necessarily be included in this basic style. Built into the osm.org website is the ID editor. So once you've logged in from that website, you can click edit and then edit an ID editor, and it will open up in that same window browser an editing interface. And this one is made to be really as user-friendly as possible, and makes it hopefully pretty simple to add in additional details. You can switch out kind of the base layer sometimes to have different imagery beneath. And this is where you can also, if you have that drone imagery hosted on Open Aerial Map, sorry, you can get the URL, plug it in, and then see your drone imagery instead of the satellite imagery as a base map here. JASM, or Java OpenStreetMap editor for the language that it's written in, is another one that you can download and install on your desktop. This one provides a little bit more functionality and control and options. So sometimes advanced editors like to use this one. Also, because you can download the data to your computer and edit it there before pushing it back, pushing the changes back up to openstreetmap.org. Sometimes this one can work a little bit better if the connectivity is slow or not so great. So to export the data and get it so you can use it, there's a number of ways as well. Two of the easiest ways, one of them is there's a website, GeoFabrik, a German company that, in addition to their paid services, also provides free OpenStreetMap extracts on their website. So you can navigate to this website, and they have on there a variety of options to download different. You can download the Philippines as shapefiles and as a couple of OpenStreetMap formats. There's also export.hotosm.org. So HOT being the humanitarian OpenStreetMap team, they're active around the world in helping to build capacity and improve the map and help people use OpenStreetMap. And on this website, you can create an export for a custom area, defining what data formats you need, what data you can choose, just healthcare facilities or just roads or all the data, what data you want. And then it will bundle up that data and allow you to download what you're interested in for where you're interested. So using the data. As mentioned before, QGIS is an excellent open source free geospatial software. And within QGIS, once you've downloaded your data from OpenStreetMap, you can load it in there and you can style it. You can use it how you want. It's useful, this data, in community planning. So in the Philippines, with the barangay spot maps and other planning exercises that the Red Cross might do with a barangay, can be very useful to have a geographically accurate, detailed map that you can use. So the data on the right was just had a very basic styling in QGIS, where buildings have been styled yellow. The There's two basketball courts that have been styled green. Roads and rivers are both lines, but they've been styled either blue or gray. And then there's also some footpaths that have been styled with the kind of the dotted dashed line. And so, using the attributes of the features, you can style it how you want. And so if in a barangay, you've gone in and you've labeled the shops, you could style shops a different color. You could, mark the locations of all the sari stores. You could show the health posts, the other civic amenities, the schools. And the more detail that's added to the map, the more options you have in showing these features. OpenStreetMap can even be used to generate 3D maps. So if you encode the data about the height of buildings, so either just like the number of levels, or you could even go in and actually measure the buildings and add an attribute for the height of the building in feet, then you can use that number to raise the height of that feature in your 3D map, and so create a visualization showing how tall everything is. There's a lot of different options for building these maps for planning. Maps are also useful in disaster response. So the more details you have, the better analysis you can do. If a place has flooded or been hit by a storm, it makes the disaster response potentially more efficient and easier if you know how many buildings were affected, how many schools were affected, if you can estimate how many households might need assistance. There's a number of different ways to collect the data. We've talked about using imagery to trace some of those basic outlines of features. So from aerial imagery from satellite, drones, planes, that imagery that is taken from directly overhead, you can see the outlines of buildings, you can see kind of larger features from us directly above, but that doesn't always get you the details that you need. When you're walking around on the ground, you can see things that you can't see from directly above, things like the names of stores, house addresses, things of that nature. ODK, which some of you might have used just for collecting survey data, for interviewing people or registering people for a humanitarian program, can also be great for collecting spatial data. One of the question types is GPS coordinates. And so you can use that to collect point locations, and then the additional questions to collect those attributes that you might be interested in, whether that's roof type or the names of stores or anything else you can think of. If you've used ODK before, you might have used XLS form. XLS form is a syntax, a standard for creating mobile data collection forms. And it's an easy way to create these, what can be a very complex survey form using just Microsoft Excel or a spreadsheet. So the details of the survey form are defined in two spreadsheets usually, one with the survey questions and one with any lists of options for answers. And on the survey form, you'll have each row be a different question, and then the columns define things about that question. So this isn't a spatial survey, but you can see in this example on the screen that the top box is the one that's defining the survey questions. The type is the format of the question. Row 2 just being a metadata, so it's automatically recording the current date. Then row 3, it's a select one type question, so it's only letting the user select one of the options from a list of answers. Male, female is referring to the list of answers that are available to the person answering the survey. Name column. Name column is the key for that survey question. So in your data export, it will be used to find the answers to that question. And then label is what it's showing to the person answering the survey. And you can add all sorts of columns to make questions required or not, to add survey logic and things of that nature. So it's possible to use XLS form and then in Excel, create a survey to collect the spatial data that you're interested about for a community, for a location. ODK is great. It's open source, so it's free to use however you want. It's not free like free lunch. It's free as in free like liberty. So you still need to have a server somewhere that you can use. So the IFRC has Kobo Toolbox, which is a part of the kind of ODK ecosystem. It's built on top of ODK source code that they've hosted and national societies can use. There's also UNOCHA, which they created Kobo Toolbox. They have a version, kobotoolbox.org, where anybody can log on and create a free account on that website and use it to host their mobile data collection forms. There's also forum.getodk.org. So thousands of people are active on this forum, and they talk about how they've used ODK. They ask questions and get help and troubleshoot and support each other in using the software. And so on here, there's also examples of people who've asked questions about how to use ODK to collect spatial data, and also people who've talked about the success stories that they've had using ODK for collecting spatial data. There's also comprehensive documentation at docs.getodk.org that describe all the different components. So the ODK Collect, the Android app, the different ODK servers, and also providing details about XLS form and how to create your survey form. A form of data collection that some of you may not have heard of is Mapillary. So street level imagery, I think, was probably made popular or made well known by Google, who has worked very hard to collect kind of street view imagery of much of the world, driving around vehicles with expensive cameras on top, and collecting imagery in other ways. Mapillary is a kind of crowdsourced street level imagery repository for the world. So instead of having one company only with very expensive professional cameras driving around, Mapillary allows anyone with either a smartphone with a GPS inside or with a action camera that can tag photos with the location. It allows them to upload those images to a website and share them with everybody else. So here, I mentioned is a screenshot of just a smartphone app, somebody getting ready to take some pictures of a street in a city here. We've used Mapillary post disasters to try and collect kind of a baseline of imagery and help collect some details about what happened immediately afterwards. This is in the Caribbean. And here you can see somebody has commented on one of the images. This really puts it into perspective, devastation across the country. So it can be a useful tool in addition to kind of capturing that moment in time after a disaster, also in sharing with people what's happened. Mapillary is useful for OpenStreetMap. You can load in ID editor the photos as an additional data layer to use when editing. So instead of having to be, with your trying to edit the details of the map on a phone or laptop while walking down the street, or remembering what you saw once you go home to your laptop or phone, you can load these images of the street on your computer and see what you would have seen as if you were walking down the street. So here's an example where, in the ID editor in the browser, you can load that map layer imagery. The little green dots are the images. The cone shapes, the triangle shapes are showing which way the image is pointing. And the yellow one is the one that is showing up in the inset image here. So clicking on the image, you are able to view the side of this store and read the details. And for this one, actually, a lot of the information was already in OpenStreetMap, but you can see that the side of the store includes the email address, and that was not included on the data. And so the person editing could add that based on this street level imagery. Here's another example where you can see the image shows the name of this Freetown drugstore, and then it can be added to the map. It shows up in that OpenStreetMap little mini map right here in the corner. Mapillary does some other interesting stuff. They use image recognition to extract certain map features like signs, lamp posts, and some other things. So here you can see that they have identified a stop sign and created a data layer that you can use to add features to the map. And there it is in the imagery shown up there. Here is an example where there was a no parking sign that they have identified and located on the map. There's some tools that people have created to use Mapillary. So one, Pick for Review, allows you to set up a project where you ask people to try and answer a set question about each of the points in your project. So in this project, they've taken all of the zebra crossings from a city, these marked pedestrian crossings, and then ask the users to look at the Mapillary imagery that's available, that's pointing at that location, and answer if it's wheelchair accessible. So if there's the cutout in the curb that would allow someone in a wheelchair to cross easily, or if they would not be able to cross. And so this is a great way to use Mapillary imagery to help understand the accessibility within a city. Here's another example where someone has used all the bus stop locations in a city, and then they're using the street level imagery to ask people to fill out the details to answer a question about if there's a shelter there, if it's only a pole, if it's only marked on the street, or if it's a pole and a bench. And so you could ask additional details about something like that as well. And so thinking about the VCA, the Vulnerability Capacity Assessment, or any of these other kind of community engagement activities that the Red Cross might do, if you're able to identify what's important to the community, what they want to work on, what they want to understand, there's a variety of tools and ways to collect those details and then get it into OpenStreetMap. You can, equip the community members or the Red Cross volunteers with smartphones running ODK, and they can go out and use that to collect the point locations of the features of interest, whether that's shops or informal dump sites or street lamps or drainage issues or bridges. You can also do things like collecting imagery, whether that's drone imagery or street level imagery, and then using that to engage like a wider group of volunteers, digital volunteers, to help add details to the map from that imagery. And just repeating what I already said yesterday, but a reminder that people in mission first, that it's not about technology or points in a game or the number of edits you can make. It's about what you're using the data for and how you're helping people to understand the world to make an improvement in their lives. So I know I went over a lot of different things today. The point of these first two sessions was really just to try and cover as much as possible to get you thinking, to get you curious, to get you asking questions. And then we can take some more time in future sessions to go a bit more slowly and dig into the topics that are of most interest and that you're most curious about using in your work. Question from Arthur in the chat. Hi, Dan. I've explored before Open Aerial Map, but not OSM just yet. I wonder if it can also provide output maps, specifically orthomosaic types. How friendly is it for beginners like me? How is OSM connected to the Pacific drone imagery dashboard project? So OpenStreetMap doesn't store the imagery or raster data. It's only for the derived, for the traced vector data. So for orthomosaics, you would need to store it somewhere else, like Open Aerial Map. And then those imagery sources would be used to add additional data to OpenStreetMap in the vector format, making it easier to style and to analyze in some cases. OpenStreetMap, I think, is very friendly for beginners. Once you create an account, the ID editor makes it very easy to do your first edits. I could even if you can pull up real quick the example, and it's accessible for all levels of learning. So when you first start, you might log in and just try and find a few buildings that are not in the data, but you can see in the satellite imagery, and then just tracing a simple square and labeling it building equals yes is a great first task. As you get more advanced and want to add administrative boundaries or do complex mapping of the details of buildings, you can kind of work your way up to those more difficult things. When you first log on to the ID editor, also it has a walkthrough tutorial that you can do to learn. Okay, here, I'll share that screen real quick. Show you all. Second. So here, the OpenStreetMap website, and I've logged in, and you can edit with ID browser. And in here, I've logged in before, so it's not prompted. It's not showing me automatically, asking me to do the walkthrough, but I can access here, start the walkthrough, and it comes through and it teaches you the basics of editing an OpenStreetMap, and walks you through all the different ways to do things. But in here, so like, let's see if I can. Looks like these buildings are all already traced. That's probably one there. So like, if I wanted to add another building, so you traced the 4 corners. There's tools that you can square a building. So if you've traced something it's a little bit crooked, you can just have the computer make the corners square. And then I can just tag it with just a basic building type. And then as soon as I hit save, I can type in just adding a building to describe what I'm doing. And if I hit upload, that building will be immediately available for anybody else who is using OpenStreetMap to see and use. How is OSM connected to the Pacific Drone Imagery Dashboard project? So I haven't heard of the Pacific Drone Imagery Dashboard project. Are you able to unmute and just give a brief explanation to the group about what that is? Or if not, can you drop a link to in the chat? Answering the next question, can we take data offline and upload it later? So yes, with JOSM, you can download data to your computer for an area and then edit it while offline and then upload it later. There's also some smartphone apps and tools that allow you to store some of that map data on your phone and edit it or view it and add to it and then upload it when you have connection. One of the challenges is that sometimes in areas, if there's a lot of people editing the map, if you're editing offline and somebody has changed the same feature online while you are offline, and then you try and upload, there might be a conflict that you have to resolve between their version and your version. And sometimes that can be a little complex, but if it's an area that's not being edited by a lot of people, it can be more rare. It won't happen very often.
Hi, Dan.
Hi, Arthur. Yes, go ahead.
I think the question is really more like, say, for example, there's no available internet connection in the actual humanitarian situation or scenario. What we have is the initial data that we gathered from, say, for example, the drone mapping, a quick as an inner response, which can be inputted into the inner report. And then once it's done and validated, and once data or internet connectivity is available, can we actually just pin it into the software and utilize it for further use? I think that's more on the side of data offline issue. Thank you.
So I think you could download all the OSM data and then like use it in QGIS and have that map to manipulate and to use how you wanted. We also, it's not working right now, but we have this software called Possum, Portable OpenStreetMap, which is intended to let you kind of put a copy of the OpenStreetMap website with just a piece of the world, so your area of interest, and load it onto a piece of portable hardware. So like a little mini computer or mini server. and then have that with you in your office or wherever that you can access, even if the internet goes offline. Go ahead, Alexi.
Yes, Dan. Good morning there. Um, I do agree with Sir Arthur. Some of the barangays, our covered barangays here in the field is with poor internet connection. That's why I question you that can we take data offline and upload it later?
Okay, yeah. If you wanted to have if you wanted to edit OpenStreetMap there in the barangay with the community, it would be a little bit more challenging and difficult to set up. I think there are ways to make that happen. The easiest way is just to, when you're doing the data collection, using the tools that work offline. So, collecting imagery that you can then take back and upload later, or using mobile data collection to collect the points and other things, or otherwise recording those details, and then providing the barangay with an extract with a copy of the data for their area later that they can then use while offline. Yeah, depending on the situation, there's different challenges, but there's a variety of solutions and possibilities for working around that low connectivity. There's a question, do we have a soft copy manual guide how to use OSM so that after this training we can practice OSM? Yes, there's a bunch of different resources, and I can email out the kind of a couple different recommended ones to get started. We could also have a short session just on getting started in OSM and go into more details about using the ID editor, using JOSM, and making your first edits. And John Eric says that with the Nokia Saving Lives drone project, the team downloaded offline maps prior to the deployment of drones, then uploaded the collected data using their software. And yeah, Lapu Lapu Dwight says, can you share it with us? And I think if you mean the OSM guides, I will share the links to the OSM guides with everyone.
Dan, do you have any specific models or drones for, say, for example, just want to have a personal drone or for my own personal practice that is not too techy, but not also, just for starters, especially for those planning to buy their own drones? Do you have any models to recommend? Thank you.
Once you are, I think the DJI drones are really some of like the best for consumers. They have very good safety features, very good cameras that are good for things. They're also, if you're just want something that you're just getting started, I'm not. There's a variety of ones that are much more inexpensive. You know, around like $100 USD or less instead of, I think the DJI drones, most of them start around 1,000 USD, which can be a big investment for someone. I'm not entirely sure like what's available easily in the Philippines, and it's been a while since I bought a drone. Unfortunately, I live in Washington D.C. and I have to drive like an hour outside of the city before I can fly a drone because of the regulations here. They don't allow people to fly drones in the city here. So I don't get as much experience as I would like having fun flying drones.
That's unfortunate though. But are there already drones that have biometrics features, like it can detect energies, for say for example humanitarian assessments for example deaths, livestock, etc.?
They do have drones that carry thermal cameras, and for detecting if there's a person there or detecting like livestock, the thermal cameras can work very well. During COVID, sometimes there were some advertisements from companies that were saying you could use a drone with a thermal camera to detect people with a fever. I think the experts criticized that as being unrealistic, that with the thermal camera that's going to be on a drone and from the distance, the drone's probably not going to be right next to someone's face, that it's not going to be able to detect accurately, the couple degrees of body temperature difference that a fever is. If a lot of times if you go to an office or the doctor and they use a temperature gun or a sensor to detect your fever, they put the sensor, almost, right on your forehead. So a drone flying 20, 30 feet away is not going to be able to accurately measure a few degrees difference in temperature, at least not the ones that are being sold by these companies. But for search and rescue, for doing identification of livestock or animals, I would think a thermal camera would work very well.
Thank you. Dan, if I may, one more last question.
Yeah, absolutely.
Uh, it's a bit personal, but what made you, decide to specialize in drones, and what triggered that interest, if I may ask, just to inspire us all, to further explore.
Yes. The history is that I've always liked exploring new technologies and looking at different ways to use technology in my work. And in, I think 2016, the United States FAA, the aviation authority here in the US, changed the rules so that you only had to take a test to be able to pass, to get the certificate so that you could fly for your work. And in the US, even nonprofits are included as commercial. You have to have the license to be able to fly as a nonprofit. So before that, to fly a drone as a nonprofit, you had to have a manned aircraft license. So you have to be able to fly a real plane, and that takes, I think, sometimes like $10,000 and many months to get your pilot license. And then after that, you could take a test and get a drone license. But there was no way I was going to spend all that time and money to get my pilot's license before I would fly a drone. But then they changed it so that you only had to pass the test. You didn't have to have the aircraft license. So at that point, I was able to start exploring how in my work I might be able to use drones, and other humanitarians have been using it for mapping, for search and rescue, for all these purposes. So I don't get to spend all my time at work on drones, but I get to spend some time looking at how the Red Cross can better use drones and learning about them and training people on them. So I just got lucky that my position includes using technology for response, and have been able to explore how drones might be one of those technologies. A lot more of my day-to-day work is on general information management. So it's most of my work is with things like spreadsheets or project management. And I'm not spending 8 hours a day working on drones. I wish I was, but I'm not.
Yeah, I thought so too. Okay, thank you.
You're welcome. Yeah, and John Eric also notes that there are some drones that have motion detectors or can identify if it's an animal or human. It depends on the programming. And so, yeah, there are, as the computing power of different mini computers and computing boards gets more powerful, and some of the technology advances, people are beginning to put machine learning programs and image detection programs directly on a drone, so that as the drone is flying, it might be able to automatically detect people or animals or something else. Or I think they did a machine learning challenge a couple of years ago where they were using drone imagery to automatically detect palm trees and other crops in the Pacific, and being able to, after a cyclone, fly the drone and have it automatically count as it's flying the number of palm trees that had been destroyed and things like that. So there's some interesting applications for these drones that people are still exploring. For the transport, the cargo drones, I think one of the things they're exploring is using, like a landing pad that has a specific design, a specific kind of painting of the ground there, that the drone can automatically detect and land in that spot. So instead of having to have someone, make sure it's coming down in the right spot, or depending on GPS alone, which can sometimes, be off by 10, 15 feet. You don't want the drone to come down 10 feet away from your landing pad, that you can have a landing pad that has that image that the drone can recognize painted on it. And then the drone can use its systems to automatically read, see that spot and come down exactly where it's supposed to. So you're asking about thermal cameras. So one of the companies that is doing thermal cameras is FLIR, F-L-I-R. And there's just an example of one that I dropped the link in the chat. But I don't know if you've ever heard the expression, if you have to ask how much it costs, you can't afford it. And so right now, the thermal cameras that they're selling, they don't tell you on the website how much it costs. You have to click request info to contact sales. So like for most people, it's probably going to be too expensive if they don't just tell you how much it costs. If you have to ask them, it's one of those things where, probably meant only for professional surveying companies, or like police departments or something that are using the rescue departments that are doing this. I think there are some cheaper ones as well. Sorry, go ahead.
I was thinking about data management sharing. Like, I know that there is a global ecosystem now drawn to contributing to the increase of data collection, monitoring, etc. Are there any regulations to protect it as well from being manipulated or used for, say, for example, activities that can cause national security issues for a particular country or region? Do we have that now, for now?
Not really. Some countries have rules and regulations about that. I think there's the rules about, certain areas you can't fly drones over or take images of. I think with a lot of this stuff, like for the governments, they already have this information available from satellites potentially. Commercially available satellite imagery only goes down to I think around like 40 centimeters resolution. So each pixel you can see up to something that's like 40 centimeters across on the ground. I think some of the governments have better capabilities that they're not sharing with the public. So they can see probably a lot of details from space already. There are some of the frameworks, just kind of informal frameworks, like the humanitarian UAV code of conduct that touch on using data appropriately and safely. Some of the countries have rules about if you're collecting drone imagery about publishing it. I don't think the Philippines really has a lot of rules on that. I think the rules become there are more rules if you're doing something like land surveying. If you're using the drone imagery for legal purposes, like land tenure, the boundaries of tax parcels or something like that, land ownership. Yeah, it's an interesting area to research and to learn about, because a lot of it's still kind of changing and evolving as the technology changes and as people learn more.
Yeah, I agree, because accountability is really something that we also need to consider seriously. Thank you.
Thank you. Great questions. And John Eric has shared a link to the partnership between Philippine Red Cross and Nokia on the Saving Lives project with the use of drones, but notes that they were in phase 3 of doing pilot testing in a real disaster scenario when the Nokia R&D department was shut down. Sorry to hear that. I was interested to hear more about that project. I didn't realize it had ended. Okay. Thank you for joining, everyone, and thank you for the great questions at the end.